taking two conductors, the conductors should have opposite charge and they should be separated by a dielectric medium. This is how we obtained a capacitor. Two conductors separated by a dielectric medium. What are dielectric mediums, Anshika? Are they conducting or non-conducting? Dielectric mediums.
Conducting.
Non-conducting. Huh? Dielectrics means non-conducting mediums. We did this calculation also. Okay, do you know any other device which can store charge? Else than capacitor. Have you heard about any other device which can store charge? This is an open question to all. Miraj, Ishma, Arpit, Saifullah, Munib.
Or a battery.
Battery, right? Charge or a battery can store charge. Then what's the difference between capacitor and a battery? See, both the devices can store charge. Huh? Battery can store charge, and this capacitor is also a charge storing device. And what's the difference between
A cell.
Cell? Yes, cell and battery are same thing. Arpit. Battery is just combination of cells. And you take more than one cell, you combine them, you get a battery. I'm asking what's the difference between a cell and a capacitor? Both store charge. So what's the difference between them? Ishma, any idea?
Capacitance can store a constant amount of charge.
And cell?
And cells are they store variable amounts.
No, both can store a fixed amount of charge. Both have finite limit up to you can charge them. Okay, see. As far as charging is concerned, cells and capacitors are same. Both store charge. But the difference is in discharging. When you take a cell, if you take a cell, then cell discharge gradually. This discharge gradually. Like if you have a yes. So
what does the capacitor looks like? Does it look? What is it exactly?
Capacity.
So
Capacitance, Arpit?
Yes, sir, capacitance.
Just the capacity of a conductor to hold charge. How much charge a conductor can hold is its capacity. Greater the capacity, greater is the amount of charge that it can hold. That's it. So I'm saying what's the difference between a capacitor and a cell? During charging, both cell and capacitor behaves in the same way. The difference is in the discharging. When a cell discharges, it discharges gradually. Means if you connect a device to a cell, like if you connect a bulb to a cell, then that bulb will have a constant glow, right? This is what happens when you connect a bulb with a cell. If you take a bulb, you connect that bulb with a cell, this bulb will have a fixed glow, a constant glow. It will dissipate a constant power. Power dissipation will be constant. But instead of cell, if you take a capacitor discharge instantaneously. Means in fractions of second, this capacitor will discharge all of its charge instantaneously. It discharges instantaneously. The capacitor discharge instantaneously. Like if you have the example of capacitor is the flashlight of a camera. Flashlight of camera. So what's the difference between a bulb which is connected to the cell and a flashlight of the camera? The flashlight of the camera in almost t equal to 0 time, the brightness was 0. Almost instantaneously, it discharged all of its charge. The brightness is maximum, then it becomes 0 again. So in a cell, it discharges gradually. The brightness of a bulb connected with the cell is almost constant. But instead of a cell, if you take a capacitor, then it discharges instantaneously. The best example is flashlight of a camera. That flash of light means this capacitor discharged all of its charge within fractions of seconds. Initially, it was fully charged, and in fractions of second, it gets fully discharged.
Sir, cell also does the same thing. If it immediately...
It can't. It can't. When you connect the same bulb with the cell, it will have a constant glow. But instead of cell, if you take a capacitor, then it will have a flash of light. It discharge all of its charge in fractions of seconds. That's the difference between a capacitor and a cell. During charging, both behaves in the same way. The difference in when they discharge. Is it clear?
Yes, sir.
Rashi, the difference between cell and capacitor? Just note it down. Okay, no one is going to ask this in your exam, but you should know at least this thing. It's what's the difference between a cell and a capacitor. So cell discharge gradually, while capacitor discharge instantaneously. Within fractions of second, capacitor just lose all of its charge. Ishma, Mazia, Minashi, noted? Anshika? Okay. Now let's start with capacitors. The first one is parallel plate capacitor. The first one is parallel plate capacitor. So you need capacitance of a parallel plate capacitor. So parallel plate capacitor means it's a capacitor which have two conductors, and those conductors are in the form of plates. So you have two plates, say one rectangular plate and another rectangular plate. These are two rectangular plates. These two rectangular conducting plates makes a parallel plate capacitor. One plate have positive charge, another plate will have negative charge. The separation between both the plates is D. This is the capacitor, and the medium between them is some non-conducting medium. For the time being, we can consider that this medium is air. You can have any medium, but for the time being, we will consider that the medium is air. The area of the plate is A. The area of the lower plate is also A. You're supposed to calculate the capacitance of the system. The surface charge density of this plate is plus sigma. The surface charge density of this plate is minus. I need capacitance of the system. So to calculate capacitance, we will first calculate the electric field between the plates. Okay, if I say that this is rectangular, its length is L, its breadth is B, then what will be the value of area?
Length into width.
Length into breadth, and area will be L into B. So parallel plate capacitor just have two plates. These two plates can be rectangular. These two plates can be circular. They can be two discs. It can be triangular. You just have two plates, one over each other. And the separation between them should be a non-conducting medium. So for the time being, we are concentrating on air, non-conducting medium. Next, you need electric field between the plates. You need electric field between plates. So when you calculate electric field between the plates, it's due to both the charges. What is the direction of field due to this positive plate? Samyullah? Saifullah, sorry. Saifullah, what will be the direction of field due to this positive plate? Upwards, downwards, right, left, here?
And downwards, sir.
Downwards. Why downwards?
Because positive are repulsive.
Yeah, positive charge, so direction of field is away from the charge. What is the direction of field due to this negative charge over this point? Hishma? Electric field due to this negative charge over this point. What's the direction?
Downward,
Downwards. Why? Why downwards?
because for negative it's towards the
It's
charge.
towards the charge. For negative charge, the direction of field is towards the charge. So this is the field due to positive charge, and this is field due to negative charge. So when you calculate field between the plates, that means the net field will be the electric field due to the positive charge and the sum of electric field due to the negative charge. So both the fields are in same direction. So when you apply parallelogram law, it reduces to E plus plus E minus. That's my first equation. Now surface charge density of the plate is sigma. How much is E plus? Does anyone remember? What is the expression of electric field due to a plane sheet, infinite plane sheet? Field.
Sir,
Yes, Arpit.
sigma by epsilon naught.
Sigma by epsilon naught. Okay. Unib, expression of field due to an infinite plane sheet. What's the expression of field?
So sigma by 2 epsilon.
Sigma by 2 epsilon naught. If you have an infinite plane sheet, then it's not sigma by epsilon naught. It's sigma by 2 epsilon naught. So E plus is sigma by 2 epsilon. E minus is also sigma by 2 epsilon naught. Like when we calculate magnitude, we don't substitute the sign. This is negative sheet, but I won't substitute minus sigma here. Sigma by 2 epsilon naught, sigma by 2 epsilon naught. It's 2 sigma by 2 epsilon naught. Now see, this 2 and 2 will cancel each other. So the field will be between the plates. Your field is sigma by epsilon naught. That is equation number 2. And how much is sigma? Mehraj. What is sigma here? Raj.
Sigma is E epsilon naught by E. E by epsilon. Epsilon naught into E.
No, I'm not asking from this expression. I'm asking what is sigma actually? What do you mean by sigma?
Surface charge.
Surface charge density. Sigma is the surface charge density of the fields. And what is the formula to calculate surface charge density? Sigma is the surface charge density. What is the formula?
Q by
Charge
A.
by area.
Yeah, it's charge upon area. It's Q upon A. That's 3. If I substitute 3 in 2, then how much is E? It's Q by A epsilon naught. Is equation number 4. Note it down, then we will calculate something else. Note it down, then we will calculate potential, and then potential will help to calculate field. Yes, written. Can I scroll it?
Yes, sir. Please scroll.
Sorry.
Please scroll.
Written.
Yes, sir.
Now you have field. That field between the plates is Q by A epsilon. Now once you have field, you can also calculate the potential difference between the plates. Once you have field, you can also calculate potential difference between plates. Potential difference between plates. So see, potential difference between the plates is the relation between field and potential is this. That a simple relation between field and potential. That field is potential difference divided by separation. That's it. If your field is uniform, then you can write this thing as the potential difference divided by separation. So here, potential difference between the plates is V. Field is E. And what is the separation between the plates? It's D. D is the
E.
separation. So you can write this V is E by D. Your E is VD. That's equation number 5. So when you, oh sorry, not E. V is ED. Yeah. So potential difference V is, you can substitute, this is 5. You can substitute 4 and 5. So V will be Q by A epsilon naught into D. That's the potential difference. So once you have potential difference, you can calculate capacitance. Capacitance C is just the ratio of Q by V. It's Q by A epsilon naught D. This Q will cancel this Q and you will have epsilon naught A by. So sorry. E is Q by A epsilon naught divided by D now. Just give me 1 second. It's Q by A epsilon naught. Sorry.
Why did you raise?
I wrote the wrong formula. Electric field is V by D. Yeah? Electric field is V by D. Potential difference divided by separation. So this is it. Now I is V by R. So V will be E into D. That's equation number 5. Now if I substitute 4 and 5, I get V is E, which is sigma over A epsilon naught into D. And your E was Q by A. This potential difference. Capacitance. C is Q by V. So it's Q by A epsilon naught to D. It's cancelled out. So the capacity is epsilon naught A by D. This is the capacitance of a parallel plate capacitor. C is epsilon naught A by D. That's the capacitance of a parallel plate capacitor. Now see, this capacitance depends upon area of the plate. It depends upon the separation, but it's absolutely independent of charge and potential. It depends only on geometry. Only on geometry of the plates. Note it down. Mazia, is it clear? This parallel plate capacitor have four types of derivations. Anshika, written.
Yes, sir.
Sefula.
Yes, sir. Done.
So this was the capacitance of parallel plate capacitor when you have air in between the plates. But if you have some other medium like parallel plate capacitor, parallel plate capacitor with dielectric in between the plates, dielectric in between the plates. So if you place dielectric medium between the plates, then you have to decide what's the capacitance. So these are two plates, one of area A, charge density plus sigma. This is another plate, plate area A, charge density minus sigma, and the medium between them is some dielectric, like you place some glass or some other thing else than air, some non-conducting material else than air. The separation between them is T. You need capacitance. So for capacitance, first we will calculate electric field between the plates. I need electric field between plates. So just like the previous calculation, electric field between the plates is sum of the electric field due to positive charge and electric field due to negative charge. So you can say that electric field is just E plus E minus. Since both the fields are acting in same directions, you can add them up algebraically. So it's E plus E minus. How much is E plus? E plus is just sigma by 2 epsilon naught. E minus, it's sigma 2 by 2 epsilon. There is some difference. This was sigma by 2 epsilon naught when you have air. Due to like dielectric, what will be the change in the expression of field? Hishma? If you have any other medium than air, and how this electric field will change?
Sigma by 2 epsilon naught into
K
epsilon naught.
epsilon naught. Yes, you'll be using K here. Both the cases. This K is the dielectric constant. The rest of the calculations are same. You'll be using dielectric constant. So your E will be, it's 2 sigma by 2K epsilon naught. This 2 will cancel this 2. And you will have sigma is Q by A. It's Q by A into K epsilon naught. That's the electric field. You can calculate potential difference also. Potential difference. You can also calculate potential difference between the plates. Potential difference between the plates is nothing but E by D. E is Q by A K epsilon naught into what was the expression of potential difference in the previous case? Unib? The relation between field and potential difference?
Sir, integral of it.
Not integral.
V by D.
E is V by D, na? So we will be E into D. See, only we need integral if your field is non-uniform. But if your field is uniform, then you don't need any integral. You can simply multiply them. So we will be E into D. So how much is E? E is Q by A K epsilon naught multiplied by D. Next, you need capacitance. Capacitance is nothing but Q by V. So it's QD by AK epsilon naught. It's QD over AK epsilon naught. This Q will cancel this Q and you will have K epsilon naught A by D. So this is the capacitance. This is K epsilon naught A by D. This is the capacitance of a parallel plate capacitor. K times epsilon naught A by D. This is the capacitance. So if you compare the result when both the plates have air in between them and when the plates have dielectric, then the difference is when you have air, it's epsilon naught A by D, but when you have dielectric, it's K epsilon naught A by D. So you can say that capacitance in a medium is K times capacitance in air. So when you place a dielectric constant, then capacitance increases. So you can say that capacitance in the medium is greater than the capacitance in air. So whenever you place some other dielectric medium between the plates of capacitor, then capacity is greater than that of free of air. Note it down. A bit just two books, SL and HCV. SL Rodara and HC Verma. That's it.
Sir, this is for like CBSC or for NEET?
The first one is for CBSC, second one is for NEET.
Okay, sir.
Anshika, any doubt?
No, sir.
Yes, written. Only Arpit.
Yes, sir.
Sure.
Yes, sir.
So in the first case, we did parallel plate capacitor when you have just air in between the plates. In the second case, we did parallel plate capacitor when both the plates have some dielectric medium between them. Next case, parallel plate capacitor. Parallel plate capacitor. With a dielectric slab partially filled between the plates. So you need parallel plate capacitor with a dielectric slab which is partially filled between the plates. So this is one plate, this is another. Now I'm just showing the top view of the plates. I'm not drawing the complete plate. This is a complete plate. I'm showing just the top view. The top view will looks like a straight line. So this is one plate. This line means it's a complete rectangle. This line means it's a complete rectangle. And between these plates, I placed a dielectric slab. The separation between both the plates is D. The thickness of the slab is T. The dielectric constant is K. So this is the dielectric. And this is air. This is dielectric and that is air. You need capacitance of the system. Minashi, what's the difference between this particular system and the case that we did earlier in this case?
In the first one, we have only dielectric medium. And
Okay.
the second one,
And
we
in the
have
second,
air.
yeah, here the dielectric is partially filled. T is just less than T. So if I draw this diagram here, then this means these are the capacitors, plates of capacitance. The whole separation is filled with the dielectric of dielectric constant. So now you need capacitance of the system. So to calculate capacitance of the system, you can write that this is air, this is dielectric, and this is air again. We know that field between the plates of capacitor is sigma by epsilon naught. It's sigma by epsilon naught. See, when you have air, then the electric field between the plates is this sigma by epsilon naught. And when you have dielectric, then electric field between the plates is this sigma by K epsilon naught. So we have both the regions, air as well as dielectric. So electric field in air, I call it as E naught. How much is field? What's the expression of field in air? It's sigma by epsilon naught or sigma by K epsilon naught. In this region, I need electric field in this region. It's sigma by epsilon, it's air. And in what thickness this air exists, the total separation between the plates is D. The thickness of the slab is T. So dielectric is in the thickness T. The remaining D minus T, this have air. So you can say that air exists in thickness T. You have air in thickness T. Similarly, you can calculate electric field in dielectric. Electric field in dielectric. So the electric field in dielectric, what is the expression of field inside dielectric, Saifullah? We did this just in the last section.
I was absent, sir.
No, just the last section here, somewhat here. Field in the dielectric. Ishma.
Q by A epsilon naught K.
Yeah, sigma by K epsilon naught. That is electric field in the dielectric. And dielectric exists dielectric exists in thickness T. Oh, sorry. Air exists in thickness T or D minus T?
D minus.
D minus T. No? The total is D. Dielectric exists in thickness T. So the remaining is D minus T. This exists in thickness D minus T. So the potential difference between the plates, V is its electric field inside air multiplied by the thickness. See, potential difference is always electric field multiplied by the separation in which the separation between the plates. So here you can write its electric field multiplied by D minus T plus electric field E. In what thickness this field E exists? Uneep? E not exists in D minus T separation. In what separation this field E exists?
Sir D.
T or T? T, na?
Sir air में भी तो करेंगे तो.
Dielectric is in T only, na? See, we are calculating potential difference for two different regions. We are calculating potential difference for this air and then for dielectric. For air, I multiplied with D minus T, but for the dielectric, I multiplied with T. Let's call this as equation number 3. Let's call this as equation number 1. Let's call this as equation number 2. When I substitute the values, then E naught will be sigma by epsilon naught. It's D minus T plus it's sigma by K epsilon naught. It's T. You can take sigma as constant. Sigma by epsilon naught I can take constant. I'll be left with D minus T plus T by K. How much is sigma? Anshika, how much is sigma?
So Q by A.
Q by A, area of the plate. So what we can do is, we can, instead of this sigma, I can substitute Q by A. When I do the substitutions, I get V is Q by A epsilon naught. It's D minus T plus T by K. That's potential difference. Let's call this as equation number 4. So when you calculate capacitance, capacitance C is just the ratio of charge and potential difference. So charge is Q and potential difference is Q by A epsilon naught. It's D minus T plus T by K. This gets cancelled out. So the capacitance is, it's epsilon naught A over D minus T plus T by K. Or you can say that capacitance is epsilon naught A over D minus. You can take T as common. When you take T, you will be left with 1 minus 1 by K. So this is the capacitance of a parallel plate capacitor when you have dielectric in between the plates. Dielectric is partially filled. It's partially filled with dielectric. And if you, let's compare this expression with that of free space. What was the capacitance of a parallel plate capacitor when the medium between the plates is air? Anshika. Mehraj, sorry, not Anshika. Mehraj. Mehraj, what is the capacitance of a parallel plate capacitor when you have air between the plates? Mehraj Rahman.
E says 0.
Capacitance when you have air.
A by D.
Epsilon naught A by D. Now let's compare this expression with this expression. This is the capacitance when you have air in between the plates. This is the capacitance when dielectric is partially filled. So if I compare this and this one and this one. This is when you have air. This is when you have dielectric. So can you compare this one and this one? Cm is greater than C air or Cm is less than C air now? Raj. This is the capacitance when dielectric is
Greater.
greater. Which one is greater? Capacitor
Sir,
with the dielectric is greater than that of air.
yes, sir.
Why? How can you
Because,
conclude?
sir, sir, the denominator is larger.
Denominator is larger in which case? In air or in medium?
Sir, in medium.
Medium, it's large or it's small. See, in air, denominator is D, but when you take medium, it's D minus something. Which one is large?
Sir,
First
D
one
is
is
larger.
D is large. This is small. Denominator is small here. Your answer was right, but reason was wrong. So in medium, the capacitance is greater than the capacitance in free space. After this, there's one more derivation. Just note it down, then we'll do the last derivation. Miraj, what topic are you doing in your school?
So in school,
Hmm.
so we are doing this chapter.
Okay. Anshika,
The same chapter.
same chapter. Uneeb,
सर यही चैप्टर चल रहा था और इसके आसपास ही हुआ था।
sorry. Minashi, Minashi, what topic, which chapter are you doing in school?
Energy stored in capacity.
Okay, capacitor only. Saifullah?
1 minute, sir.
Ishma?
The magnetic effects of electrical.
You're doing chapter number 4.
Yes, sir.
You're from Bahrain, Ishma? No.
Sorry, sir.
You're from Bahrain, na?
No, Kuwait.
Kuwait. Okay. Which school?
Indian public school.
Okay. So vacations have started or school hours still open?
So Thursday to go tomorrow.
Tomorrow's the last class.
Yes, sir.
And then when will your school will reopen?
August 22nd.
August, okay, 2 months you have. Yes, Saifullah, what topic are you in school? Written? Raj.
Done, sir.
So after this, we will find capacitance. The next case is again parallel plate capacitor. Parallel plate capacitor with conducting slab. With conducting slab. Partially filled up. Conducting slab partially filled between plates. So you have parallel plate capacitor with a dielectric slab partially filled. Then you have parallel plate capacitor with a conducting slab partially filled. So this is parallel plate capacitor. You take a conducting slab. This is a conductor. Thickness is T. The separation between them is D. And T is less than T. And again, this is air and this is conductor. So electric field in air is electric field, just like the previous calculation. Electric field in air. So electric field in air is epsilon naught, or sorry. What was the expression of field in air, Arpit? Arpit,
Yes, sir.
field in air. Sigma by epsilon naught. And electric field in conductor Electric field in conductor. Miraj, what is the expression of field inside a conductor? Raj. Minashi, expression of field inside a conductor. Hishma, what is the expression for field inside a conductor?
0.
Zero. There's no field inside the conductor. You can calculate potential difference between plates. Potential difference between plates. Miraj, how we calculate potential difference if we have field? Miraj, this we did in the last three calculations. How you calculate potential difference if you know field? Anshika, you have field. How do you calculate potential difference?
So E into D.
E to D. So it's E naught. And what is the thickness in which this air exists? Yes, Anshika. In which thickness does this air exist? It exists in thickness T or thickness D minus T?
So D minus T.
D minus T plus it's E. This exists in thickness T. E naught you can write as sigma by epsilon naught D minus T. E you can write as 0. No, there's no field in the conductor. 0. So you can write that your potential difference is sigma by epsilon naught T minus T naught. And how much is sigma? Sigma is nothing but Q by A. So you can write that V is Q by A epsilon naught T minus T. So when you have potential difference, you can calculate capacitance. Capacitance is easy calculation. Capacitance C is just the ratio of charge and potential difference. So it's Q by A epsilon naught into D minus T. This Q will cancel this Q and you will be left with its epsilon naught A by D minus T naught. So this is the capacitance. So if you have conducting slab between the plates, then the capacitance is epsilon naught A by D minus T naught. If you compare it with air between the plates, it's still greater. Because if you have air between the plates, then capacitance is epsilon naught A by D. Now it's D minus T. Denominator is small. So overall fraction is large. Note it down. Then we'll do a few numericals now.
सर इसमें पिछले केस में क्या फर्क है?
In last case, you had dielectric. Here you have conductor. That's the difference. Okay.
Yes.
In dielectric, field is sigma by K epsilon naught. But you have conductor, then field is sigma by epsilon. Yes, written everyone? Saifullah, Miraj,
Yes.
Mirashi, written. Okay, let's do two simple questions. Basically, the four derivations that we did, now you won't get many numericals on this topic. Only derivations comes. These are two numericals based on these derivations in NCERT. Start your calculations and write your answer in chat. Do it. Okay, can you do one thing? Like, can you send your answers on WhatsApp, on my WhatsApp number? Or you have the WhatsApp number of Learnivio, na? The one from which you get meeting invitations daily. Hello?
Yes, sir.
You have that number. So do one thing, just solve this question and send your answer on that WhatsApp number. Does everyone have access of phone right now? Chika,
No,
Arpit,
sir.
you don't have. Raj.
Sir, no, sir, I'm currently taking the laptop, the class on my laptop.
Okay. I want to see your notebook. You can do one thing, Anshika. I have started the focus mode, so you know focus mode. In focus mode, no one else can see your videos than me. So you can do one thing, just switch on your webcam and just put your notebook in front of you. I can at least see
Yes.
your calculation. That would be easy. Let's do this experiment if it works. So I want to see these calculation steps in first these two questions. And whenever I take class, I open this focus mode. So when the focus mode is open in Zoom, no one else can see your video else than the host, which is usually the faculty. The faculty can see your video, not you. Who else does not have access of mobile phone? Anshika don't have, Miraj don't. Minashi, Saifullah, Hishma, Unib. You all have access of phone?
No.
Yes, sir.
Okay, if you have access of phone, you can do you can just WhatsApp me on that number. And if you don't have, you can just switch on your video and share your calculations. Answers. Yes, does anyone finish these calculations? Arpit. Should not take this much time. A simple calculation. Saifullah, done?
Almost, sir.
Almost. Minashi, Hishma,
Doing.
doing. Hishma, done.
No, sir, nothing.
सर सब्सटेंस जो है उसको स्लैब की तरह ट्रीट करेंगे या फिर मीडियम?
Slab, like slab dielectric. See, space between them is filled with substance of dielectric constant 6, the dielectric slab which fully filled the space. If it is partially filled, then it would be given in the calculation. So that will be case 2, I guess. Case 2, no? In the case 1, it was air. In the case 2, there was dielectric slab which fills the whole space. Third was partial, and then fourth was contact. Second case. The small calculations, but it should not take more than 2-3 minutes. Simple 2-line calculations. And please don't take help from Google. Anshika, are you solving it?
Yes, sir.
Do it fast. Should I solve it? Yes, no one is. Sefula, Minashi, should I solve this question?
Yes, sir.
Okay. Minashi? Okay, see the simple calculation. You have a parallel plate capacitor with air.
Sir, I've done it.
You have done it. Anshika, just show me your calculations. Switch on the video, just put this calculations. Yes, it's visible, it's visible, it's visible, it's visible. Just 1 second. Okay. Just one small issue. Just 1 second, Anshika. Good, very good. Anshika is right. Correct. Anyone else? Ishma? Sefula? Raj? No one solved the question. See, you have a parallel plate capacitor where air between the plates has a capacitance of 8 microfarad. See, the formula for a parallel plate capacitor is this: it's epsilon naught A divided by D. And how much is it? It's 8 picofarad. Pico means 10 raised to the power minus 2. First equation. You need capacitance if the distance between the plates is reduced by half. How much is D now? Sefula?
D by 2.
D by 2. So this is D by 2. And what else? It's a dielectric constant 6, means you have a K here, right? You can take this 2 in the numerator. You have 2K by epsilon naught A by D. Is it clear, Unib?
Sir, I sent you the answer.
Send me the answer. I didn't get your. You sent on my number.
Yes, sir.
That's off. Switched off. Right over. Okay, this is 2K epsilon naught A by D. It's 2. How much is K? K is 6. And what is epsilon naught A by D? That's 18 to 10 raised to minus 2. So what's the answer? This is 12 8s are 96 into 10 raised to the power minus 2. Is it clear? Minashi? Ishma? Only if you're getting the same answer?
सर मेरा थोड़ा सा अलग है.
हाँ गड़बड़ करो. Anshika was right. Note it down. A simple calculation, 2-line calculation, should not take more than 2-3 minutes.
So the area and distance are variables. So they are
Area is not variable. See, area is not changing. Area is earlier it was A, now again it's A. So what I did is instead of this epsilon naught A by D, now I substitute this value. You know that epsilon naught A by D is 80 to 10 raised to power minus 12. So instead of this thing, I just substitute this value. Clear?
yes, sir.
Okay.
सर सही था मेरा, बस मैंने 12 into 8 को 72 लिख दिया 96.
अच्छा 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 चलो good. Let's move on to next question. And only please share your answers on the Learnivio's number. My phone is switched off.
Okay.
Can I scroll it?
Yes, sir.
In exercise 2.8, and this is what? This is 2.5. Array. Just 1 second. Let me take 2.8 also. Okay, do this calculation and then just you don't have to solve 2.8, you have to solve 2.9, but 2.9 is taking some reference to 2.8. Do it fast, right? Or send your answers. If you don't have access to mobile phone, just tell me, we can do it on your webcam also. I want to see your calculations. See, this is 9:52. Should not take more than 3 minutes. 9:55, I will start calculating. Do it
Both
fast.
the questions.
No, not both the push, just 2.9. 2.9 will use this 2.8 in exercise 2.8. You have to solve 2.9 only. Just solve 2.9 and write your answer in chat. Don't take help from Google. Exams won't be online this time. This time exams would be offline. Yes, 9:55. No answers. Anshika, done.
I have solved the first part.
Solve the first part. Okay, just show me the first part. Just 1 second. Just 1 second. Let me just do this thing. Okay, you have K, fine. You have V, you have C, you calculated capacity. Very good. The charge will change, fine. And what happens with the potential difference, Anshika? Does it change or it will remain constant?
So for the first one, it is constant. Like it will remain the same.
It will remain the same.
Connected.
Yes. What will happen when the supply voltage is connected? No one else sends me the answer. Huh? I will solve it. It's a simple calculation. This is a capacitor, parallel plate capacitor with air between the plates. This is the plate area. This is the plate separation. This is the voltage 100 volts. So your C is epsilon naught A divided by D. This is 8.85 into 10 raised power minus 12 into plate area, which is 6 into 10 raised power minus 3 divided by D, which is separation 3 mm. 3 into 10 raised power minus 3 farad. So it's asking what will happen if you introduce a dielectric of dielectric constant 6 between the plates, a 3 mm mica sheet. So what does it mean? Is it inserting the sheet partially or fully? Ishma, what do you think? 3 mm thick sheet. Is inserting the sheet partially or fully between the plates of capacity? No answer from Ishma. Minashi?
Partially.
Partially, okay. Saifullah? It's partially. Fully. See, the separation between the plates is 3 mm. Thickness of the sheet is 3 mm. So it's not partially filled, it's fully filled. Only some issues with the calculations. Huh? You took it as partially filled. It's not partially filled, it's fully filled. See, the separation between the plates is 3 mm. Your slab thickness is also 3 mm. So it's fully filled up. So capacitance will be K epsilon naught A by D. So this is capacitance when you have air. So capacitance will be 6 times that of air. So capacitance will change. When the voltage is connected, that means your potential will not change. Earlier, when it was air, the potential difference between the plates was 100 volt. After inserting the dielectric, if the battery remains connected, that means potential will not change. It will be still 100 volt. Charge will change. See, earlier the charge was CV, but now the charge will be its CM into VM. See, charge will change because capacity changes, so charge will change. Is it clear? So when your battery remains connected, then capacity will change, potential will not change, and charge will change. Charge will increase exactly. And when your battery is disconnected, B part, when the battery is disconnected, there's no effect on capacitance. Capacitance will be K epsilon naught A by D only. But when you disconnect the battery, the charge remains constant. Means the charge now is the charge in air. This is charge in air. But the potential will change. Potential is C. C is equal to QV. V is C by Q. CM by Q. So when the battery was connected, potential was constant. And the battery is disconnected. Its charge which remains constant. That was the question. Do it. So I'm not calculating the numerical values. It's a homework that you will solve this numerical value and share that your calculations on the group. And from the next class onwards, if possible, please keep a mobile phone with you so that you can take a picture and can WhatsApp to me. Haji, clear? Saifullah didn't tell me what topic are you doing in school.
I don't know, sir. I was absent for a week.
You're absent. So before 1 week, what topic you were doing?
We were doing capacitors.
Capacitors you were doing. Okay, so probably in 1 week you must have finished capacitors. Okay, that means we are going right phase, except for Hishma. Hishma is doing chapter number 4. But Hishma, in the summer break, we'll cover it up. Cover it up. See, if you have issue in understanding this problem, in the next class, we'll do this numerical again. We'll do a theoretical topic in which we'll be using these calculations. Haji, is it clear? Written